Good morning, dear students. My name is Ferhan Mazher, and today is 15th of February 2022. Right now, I am with the 9th Cambridge class, and the subject we are studying is DMaths 4024. This is Cambridge O-Levels Mathematics. We are working on the syllabus, and the book we are studying is D3. The name of the book is New Syllabus Mathematics 7th edition. We are working on the chapter number 11, and the chapter is about congruent and similar triangles. We have set our hearts to solve exercise 11C today. These are story sums, or you can say they are word problems related with the similar and the congruent triangles. In this exercise, we will practice all the congruent tests and the similarity tests. Especially, you remember the congruent tests are side, 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 angle, side, angle, angle, side, and RHS. And for the similarity test, we will go with the angle, angle, and the side, angle, side test. So let's start today's exercise, and I hope that you will enjoy this exercise and you will learn a lot from this exercise. So let's start our work, and today the exercise we selected is 11C, and these are story sums, and this is from the D3 book. Okay. So the first question coming up on your screen is the question number 1. He says, the diagram illustrates how the length AB, which cannot be measured directly, of a pond is measured. Choose a point C and measure the length of AC and the length BC. Produce AC and BC to A prime and B prime respectively, so that the CA prime is equals to AC and the CB prime is equals to BC. By measuring the length of B prime, A prime, we will be able to find the length of AB. Why is this so? Okay, so here we have, if you look at this diagram, here we have a pond, and I cannot measure directly the length AB. So the technique they have used, they have chosen a point C, and they have measured how much is AC, and then they have prolonged along this line from C to A prime. The C to A prime is equals to CA, and from B they joined it with the point C. The BC line, they prolonged it to CB prime such a way that the CB prime is equals to the CB. So then they say that A prime and the B prime, they will be representing the length AB. We will prove that why the A prime, B prime will be equals to the length AB. So the methodology is very simple. This question might look very difficult, but actual question is very simple. We have to actually prove that this triangle and this triangle, they are congruent to each other. So if they are congruent to each other, then the AB side will be equals to the A prime, B prime side. So how I can prove that this triangle is congruent? You see, this AC is equals to the A prime C, because it's given, and the BC equals to B prime C. It is given. The ACB angle is equals to the A prime C B prime, because they are vertically opposite angles. So by this, I can prove that these two triangles are congruent. And then I can say that the AB side is equals to the A prime B prime. Let me show you my written solution. So here we go. So AC is equals to A prime C, that is given in the question. BC is equals to B prime C, that is also given in the question. So ACB angle is equals to the A prime C B prime, because they are vertically opposite angles. So the triangle ACB will be congruent to the triangle A prime C B prime. The reason is side, angle, side. So we can say that the AB side will be equals to the A prime B prime, because they are the corresponding sides of the congruent triangles. So AB was the width of that pond. So if you measure the A prime, B prime, that will be equals to AB, which is the width of the pond. So this is how you will prove the question number 1. Okay, so let's go to the question number 2. He says, to measure the width of the internal trough AB of a machine tool which cannot be measured directly, we make use of a device as shown in the diagram. The device is made up of 2 parts, A prime and B prime, hinged halfway at the O. By measuring the distance between A prime and B prime, we will be able to obtain the length AB. Why is this so? Okay, so here we have that tool, and A prime, this point bisects that length. B and B prime, this O point bisects that length. So it means OA is equals to O prime, and it means that the OB is equals to the OB prime. And we have to prove that this AB will be equals to A prime B prime. So the methodology is very simple. We will prove that the triangle AOB is congruent to the triangle A prime OB prime. For that purpose, you see the OA side will be equals to OA prime. It's given. OB will be equals to OB prime. That is also given. And the angle AOB will be equals to A prime OB prime, because they are vertically opposite. So that this is how you can prove that these 2 triangles are congruent. And once you have proven that they are congruent, then AB side will be equals to A prime B prime. Very simple. Hopefully you understand. Okay, so this is how you will write this argument. OA is equals to OA prime. The reason is OA and OA prime are both half of the AA prime by 2. So OB equals to OB prime, because OB and OB prime, they both are half of the BB prime. And the angle AOB is equals to the A prime OB prime, and the angle A prime OB prime, because they are vertically opposite angles. So I can say that the triangle AOB is congruent to the triangle A prime OB prime. The reason is side angle side. So I can say that the AB, that's the length of that trough, will be equals to A prime B prime, because they are the corresponding sides of the congruent triangle. So this is how you will prove that the AB is equals to the A prime B prime. I hopeful that you have understood this question. So that was the question number 2. Let's go to the next question. The figure shows a tree SR and a pole PQ casting shadows of length 30 meter and 15 meter respectively. If the height of the pole is 4 meter, find the height of the tree. You can see if you take this triangle POQ and the triangle SOR, and I will prove that these 2 triangles, they are similar to each other. Then by taking the ratio of the corresponding sides, we will be able to find out the height of this tree. One thing which you should understand is that the tree is vertical to the ground. So the angle here is 90. This pole is also vertical to the ground. So this angle will be 90. We are supposing that they are vertical. So let's prove that, and very easily I can prove that these 2 triangles are similar. So the PQO is equals to SRO is equals to 9, because both these angles are 90. The POQ angle and the SOR angle, they are equal to each other because they are common angle to both the triangles. So the triangle POQ is similar to the triangle SOR. The reason is angle similarity test. So because both the triangles are similar, so I can take the ratio of the corresponding sides. For example, PO divided by SO equals to POQ divided by OR equals to PQ divided by SR. I know the values of some of them. So PO by SO, I don't know their values. OQ is 15, OR is 30, PQ is 4, SR is the question. So I will use these two fractions, and so 15 by 30 is equals to 4 by SR. SR is equals to 4 into 30 divided by 15. So the SR is equals to 8 meter. So the height of the tree is 8 meter. I hope you understand how we have proven that those two triangles were similar to each other. And then because they were similar to each other, so once I have proven that they are similar to each other, then by using the ratio of the corresponding sides of the similar triangles, we are able to find the height of the tree. I hope that you have understood this question. Okay, so let's move to the next question. In the diagram, the P lies on the OA and the Q lies on the OB, such that OP equals to OQ. So this OP is equals to OQ. So it's given that these two sides are equal. Place a set square with one side along the PQ and another side passing through the O. So they have placed a set square. I don't think that you all can see this set square, because this scanning is not that good, but you can see this is a set square placed here. Here is the 90-degree angle. So I'm passing to the O as shown in the diagram. Explain why the OC is the angle bisector of the AOB. I have to prove that OC is the angle bisector of the AOB. So I have to prove basically that the POC angle is equal to the QOC angle. Then that will mean that the OC is the angle bisector of the AOB angle. So first of all, I prove these two triangles are similar to each other. So let me show you how I will prove that. So the question number 4 is coming up on your screen. He says OP equals to OQ. These sides, it was given in the question that they are equal to each other. They are congruent to each other. PCO angle, QCO angle, they both are 90-degree because we have placed a set square there. That set square was not very visible there. And the OC is equals to the OC. That's the common side in both the triangles. So the triangle OCP is congruent to the triangle OCQ. You can say RHS because these two triangles are right angle triangles. You compared them, you found that their hypotenuse are same and another side is same. So I can say RHS. So these two triangles are congruent to each other. Because these two triangles are congruent to each other, so the angle POC will be equals to that angle QOC. The reason is because these are the corresponding angles of the congruent triangles. So because POC and the QOC, they are equal to each other, the angles are equal to each other. So I can say that the OC is the angle bisector of the angle AOB. I hope you understand, and I hope you can see the set squares there. If you have your book with you, you will be clearly able to see that set square placed here. I hope you can see this set square here. Okay, so here we go. The next question, the question number 5 is showing up on your screen. He says the diagram shows Ethan standing at a point A along a river bank. He looks directly across the opposite bank, adjusting his cap so that his line of vision, CB, passes through the lowest point at the rim of his cap and falls on the point B. He then turns around without moving his head. His new line of vision, CB prime, through the lowest point at the rim of his cap, now falls at a point B prime on the same side of the river. State which measurement he can make in order to find the width AB of the river. Explain your answer. So this is a very good technique. This boy is wearing a cap. So he looks through his cap, and at the rim of his cap, whatever points on the ground he can see, he's looking actually on the other bank of the river. You don't know how wide this river is. So then without moving his head, he looks on the dry land, and wherever, without moving his head. So wherever this rim, he looks on this side. So whatever point on the dry ground touches, coincides with his rim when he see through the when he see. So he measured the length from where he's standing to that point, whatever is that length, that will be the length of the river. And we have to prove that how, which length he has to measure. So the basic thing which you have to do, you have to prove that these two triangles, this triangle and this triangle, the ACB triangle and the ACB prime triangle, they both are congruent to each other. The methodology is very simple. Angle made here is equals to the angle made here. It is given. The angle here is 90. The angle here is 90 because the boy is standing perpendicularly to the ground, and this AC side is common in both the triangles. So you can say that this is the angle side postulate, or you can say angle side angle. So these two triangles will be congruent. So once you know, then we will see the AB side is equals to the which side. So that will be that whatever AB is corresponding to whatever side, that side will give me the length of the AB indirectly. So let me show you. Okay, so the question number 5, ACB angle is equals to the ACB prime angle. That is the angle of the line of sight with the vertical buoy. So on both the sides, the angle was same. So it is given. CAB angle is equals to the CAB prime. That's the perpendicular to the ground in both the sides. The buoy was perpendicular to the ground. That's the angle which the buoy is making with the ground. So that's 90. So, and the CA, which is the height of the buoy, is equals to CA. That's the common side in both the triangles. So this is the height of the buoy, which is common to both the triangles. So that is a common side. So now I can say that the triangle CAB is congruent to the triangle CAB prime. So you can say angle side, or you can say angle side angle. Normally we say angle side. So these two triangles are congruent. So the AB from here, AB will be equals to AB prime. So AB will be equals to the AB prime. These are the corresponding sides of a congruent triangle. So if you want to measure the width of the river AB, that will be AB prime. Question number 6 is showing up on your screen. A candle is placed 15 centimeter from a lens. Okay. A screen is placed at a distance of X centimeter from the lens as shown in the diagram. The image of the candle DE captured on the screen is inverted and is 3 times the length of the candle. So the ratio between the AC and the ED is 1/3, means AC is 1 and the ED is 3. And find the value of that. So we have to find the value. So how you will do this? I will prove that these two triangles, these are triangles, they are similar to each other. So this angle here is 90, this angle here is 90, and this angle and this the angle, they are vertically opposite. So these two triangles were similar. Then I will take the ratio of the corresponding sides, and from there, very easily, I can find the length X, which is BD. Okay, so let me show you how I have done this. So the CAB angle is equals to the EDB angle. Both of them, they are 90 degree because the candle is perpendicular to the principal axis, and the screen is also perpendicular to the principal axis. The ABC angle is equals to the DBE angle because they are vertically opposite angles. The triangle ABC is similar to the triangle DBE, the angle similarity test. So now I can take, because both the triangles are similar, so I can take the ratio of the corresponding sides. So from here, AB will be divided by DB equals to AC divided by DE. So I know their values. AB is 15, DB is X, AC is 1, DE is 3. So X will be 45 centimeter. Hopefully you understand this question. So let's go to the next question. The next question coming up on your screen is question number 7. Using a set square, we can bisect a given angle. In the diagram, P and Q are marked along the arms OA and OB of angle AOB respectively, such that OP equals to OQ moves a 90, 45, 45 set square. This is the small set square. You know, in your geometry box, you always have two set squares. One is a big set square. One is a small set square. That small one is 90, 45, 45. It's a 90-degree triangle, and it's a right angle triangle. It's two small angles, both are of 45, 45. It's an isosceles triangle. So its two sides are equal. One is hypotenuse, the other two sides perpendicular and base. They both are equal to each other. That's the property of the 90, 45, 45 set square. So move a 90, 45, 45 set square away from O until the 45-degree edges coincides with the P and Q. Can you see that? This is very dim. This scanning is not that good, but you can see that. Can you see that? This is the set square placed here. So this is PM and the QM are the two sides which are equal to each other of that set square. This is the 90-degree angle of that set square. So explain why OM is the angle bisector of the AOB. Okay, so I have to prove basically that this angle and this angle is same. So then clearly OM is the bisector of that angle. So let me show you how this is done. So the OP is equals to OQ, that is given. PM is equals to the QM because they are the equal sides of the 90, 45, 45 set square. OM is equals to OM because this is the common side of those two triangles. So the triangle OPM is congruent to the triangle OQM, side, side, side. So the POM angle will be equals to the QOM because they are the corresponding angles of the congruent triangles. So the OM is the angle bisector of the angle AOB. And remember one thing, the spellings which I did for the congruent are wrong. CONGRUENT should be the spellings. RUENT. Okay, so correct this mistake. So everybody, we are done with the this exercise. So my dear students, today we have done exercise 11C from the book D3. We have done in this video the whole exercise. These were the story sums related with the congruent and the similar triangles. I have tried my best to explain you the concepts. If you think that this video has helped you to understand the concepts, please share the link of this video onto your Instagram accounts, onto your Twitter accounts, and onto your Facebook accounts. If you have really learned something from this video, please subscribe my channel. Also like this video. It's a great blessing for me to be teaching you online through the YouTube. So thank you very much, everybody. Have a good day and God bless you all.